So for our senior project, we designed and developed the Ice Scratcher boat. I'm Jack Wolf.
I'm Andrew Pierce.
And I'm Brock Craner. The Ice Scratcher boat was designed and developed using MET course curriculum. Some of the courses we used include mechanical systems design, mechanical design principles, manufacturing processes, material science, and solid modeling. The Ice Scratcher boat is a unique transportation alternative for those who are looking to traverse large bodies of ice, and is the perfect ice fishing application for those ice fishermen who are looking to travel to and from their favorite ice fishing hole with their gear safely and effectively.
Alright, so some talking points. What we'll go over is the design. We have the main frame, which the boat sits on. We have the drive system frame, all the drive system components that attach to the drive frame, the drive wheel, the guards, and then we'll talk about how it all goes together in an assembly. So the design, we developed it using SolidWorks for all the 3D modeling. We developed all the working industrial drawings, all the assembly drawings, the detailed drawings, and the bill of materials for all the components. As Brock mentioned, we use mechanical design principles and mechanical systems design for all the calculations for sizing and selecting the components. So the boat and the frame and the drive system are all removable, and that makes it easy to transport, easy to store, and for maintenance purposes, you can take stuff apart to fix it or to repair a part. We chose the structural steel frames because the steel would slide along ice a lot better than the bottom of the boat. The steel is a lot more durable in the bottom of the aluminum boat, and the steel was easily purchased and it's easy to work with when it comes to cutting and welding.
So the main frame is constructed of 2" by 2" structural steel square tubing. The material is A500 round grade B. The columns, struts, skis, and angle pieces are all joined together using MIG welding processes. And after the grinding and welding was finished, it was primed and painted black. The mainframe was initially designed for a 10-foot aluminum John boat, but it can accommodate different size boats. This includes a range of 8 feet to 14 feet. The angled front skis are used to jump over any uneven surfaces or snow while remaining in contact with the ice. And the boat is attached to the mainframe using turnbuckles. The drive system frame is constructed using 1" by 1" structural square steel tubing. The material is A500 round grade B, and all of the components are welded using MIG welding processes. And just like the main frame, the drive system frame was primed and painted for aesthetic purposes. The drive system frame is separate from both the boat and the main frame. It has a steerable design thanks to the inner and outer tubes seen here. The Ice Scratcher boat is now allowed with these tubes to have a turning radius, as well as up and down vertical motion, so the drive wheel can remain in constant contact with the ice. And the captain of the boat will be able to sit at the back seat and man the handle to steer the boat back and forth. The custom fabrication of clamping bolts seen here were used to secure the drive frame to the boat itself, and the connection plates, also seen here, were used to join the drive system frame to the main frame.
So our drive system components, they were all calculated in size using stuff that we learned in our classes, mainly mechanical design principles and mechanical system design. Our materials were acquired through multiple places, but we try to use commonly purchased parts with as little fabrication as possible. These parts were paid for with donations and funding from the school, and also some of it was personally owned. So for our drive system, we have a belt drive system starting from the engine, which is a 5 horsepower Briggs & Stratton engine. It has a centrifugal clutch on the engine, so the engine can idle when the boat is not moving. And we used 3V sheave and belt. And the drive system reduced our RPM from 2,400 RPM to 1,331 RPM. And then we had a chain drive system, And the chain drive system was driven through a jack shaft, which our belt drive system was connected to. And for our chain drive system, we used number 60 roller chain with a 3/4 inch pitch. And on our jack shaft, we had an 11-tooth drive sprocket. And on our drive shaft, we had a 22-tooth drive sprocket, driven sprocket. So that reduced our RPMs from 1,331 down to 665 RPM. And we use type 1 lubrication technique, which is just lubrication by hand. So here are some pictures of our drive system. So here you can see our belt drive coming from the engine with the centrifugal clutch. And that goes to our jack shaft, all with a 3V shifts and a 3V belt. And then here's our jack shaft that connects our belt drive to our chain drive. And over there you can see our chain drive going from our jack shaft down to our drive shaft. And then the chain drive drives the drive shaft, which has the studded wheel on it. So the drive wheel, it was made out of a steel cart wheel from a torch cart, and we studded it with 3/8 nuts and bolts, and we had to make a custom bushing to go inside the hub of the wheel to fit on the drive shaft with a keyway. And it weighs about 15 pounds at a diameter of 18 inches, and this wheel is in constant contact with the ice surface, and this is the scratcher part of the ice scratcher boat. So to cover up our belt drive, chain drive, and our drive wheel, we had to make guards. So we have a fender guard, belt guard, and chain guard. And these all comply with the OSHA 1910-219 code. And they were made out of 22 gauge cold rolled sheet metal. So to fabricate these, the fender was cut into the shape and then bent, and the seams were welded. And the other two were put together using pop rivets. And we welded tabs on them so it could bolt right to the frame. And then the guards were painted to look like the frame.
Alright, and then it all comes together in the assembly. So the boat attaches to the main frame, as Brock mentioned, with turnbuckles. The drive system frame attaches to the main frame with the connecting plates, as you can see here, with the bolts. The drive system attaches to the bolt up here with the bolt clamps that we fabricated. And then the guards attached to the drive system with bolt tabs, as you can see here. Thank you.
Thank you.